So I want to thank you for inviting me to discuss what is happening in the United States in regards to material recovery and what implications this may have on greenhouse gas loading. Now, in the US, we are starting to face a crisis, and this crisis actually is a result of multiple drivers that have come together at this particular time to cause a reckoning for our solid waste management systems, specifically for recycling and recovery of materials. Since about 2000, you started to see a flattening off of the increase of recycling in the United States, though there has been a significant increase in composting over that same amount of time. And up through 2015, the U.S. Average material recycled and composted has been approximately 35%, and it hasn't changed since then. In fact, it has actually started to decrease, and that's what I want to talk to you today about. The complexity behind the loss of the materials recovery, actually, the waves for this crisis, as we call it, actually began decades ago, and as the different trends sort of converged, we are facing a drop in recycling and recovery of materials in the U.S. One of those trends was the industry consolidation of the waste management sector, both the vertical integration from collection all the way up through landfilling, as well as a coalition, or basically the reduction in the number of firms that are seen in the United States. A second trend was basically began back in the 70s to increase collection efficiency, and this makes sense for a waste management business. However, this move to collection efficiency has had ramifications that has reduced the ability to move materials to markets based on current specifications. And this linkage is primarily with how material is being processed and the efficiency of processing of the material coming from the collection system. And the last trend is just basically there has been a major shift in market specifications for a significant amount of materials that were going overseas to be recovered. One might consider this a perfect storm of where these four trends have come together, and has caused what we're seeing in the U.S. And actually also in Europe to some extent. So let's talk about the industry consolidation first. If you see that the public companies, that means public companies being traded on the stock market, and there's private companies that basically are sole ownership and not traded, you can see that the percentage of control of the solid waste sector has grown dramatically in the private sector as opposed to the public sector, which has increased a little bit. And so, privately held haulers, that's collection systems from 1997 to 2005, you can see the percentage of privately held haulers has decreased significantly. And one reason for this is that there's been a consolidation of companies where you can see that a significant amount of waste management in the U.S., and we're talking, upwards to 70 to 75% of waste management is controlled just by 4 firms. And as a result, they have bought out all those small private hauling companies and consolidated them under one corporate umbrella. And so there's 56,000 companies currently in the US. 4 companies are really controlling a significant amount of material that is both being recovered as well as being disposed. 10 of these companies control 75% of the landfill capacity in urban areas, and 50% of the hauling infrastructure. And as a result, 50% of the processing infrastructure also. Now, what about this collection efficiency trend? Well, this really starts back in the 70s, where instead of having paper drives and Boy Scout collections, we really started to see an institutionalization of collections of materials. The first 2 being in Oregon and Massachusetts in the United States, where people brought materials to a drop-off. The quality control occurred right at that point where they would set out materials, and the staff at these drop-offs would make sure that each material is in its proper bin and then went to its own marketplace. To increase the participation and capture rate of recyclables, you saw, especially as in the more urban areas, you started the beginning of curbside collection of recyclables. Now, the recyclables were still set out as separate entities. They were source separated, but they were collected by the driver, and this is one of the first in the nations. This is EcoCycle in Boulder, Colorado. And the driver was the quality control. They would basically put the material in different places within the collection vehicle so that each material was what was clean enough and not mixed with any other thing, so it could go to its own individual market. In 1987, there was a sort of a watershed moment. Actually, Ann Scheinberg, who is at this meeting, participated in this, as did myself and a number of other people, where we took 2 models that were out there separately. One was the collection of co-mingled containers as one collection source, and then fiber as a second collection source. This blue box system was first used in Canada, and so we took that and then combined it with processing capacity, that instead of having households or the driver separate materials, we would have that automated. And this really grew out of the refuse-derived fuel industry that basically had separated out of the waste stream not only fuel, but high-valued recyclables and even some organics for composting. The first facility in the US was in Delaware. And so taking these 2 different models and bringing them together and doing it as a public sector entity was allowing higher capture rate, and the blue boxes actually allowed higher set out rate by households. And as a result, we had a higher recovery rate after processing. Now, through this processing, the contamination rate was approximately 5%. That is, of the material coming in, about 5% by weight was separated out and went to a landfill. Now, this is a public-private sector initiative in the sense that the public sector started to mandate that recyclables be collected, and we're starting to ban certain materials from landfills. The private sector is basically the operations of the facilities and the hauling companies was private sector, but the two together provided a material that signaled in user markets that we were able to produce a high quality input material that they could take with confidence and substitute virgin material in their production. So we increased the capture rate. The quality control was at the facility, not at the curb. And the economic driver behind this was avoided disposal costs. That is material going through this system was not disposed of, and there was no tipping fee paid at the landfill. And there is revenue made from selling the recyclables. And so not only avoided disposal costs, but revenue of sale was the economic driver. Then in the 90s, a new model in California started to come on the landscape. This is known as single stream curbside. And instead of separating containers into one component in the collection truck and then fiber in another, everything was put in as far as recovered materials into the same container and crushed. And then this material was going to be sent to a processing facility that would basically then separate the materials out. The challenge was that these things started with relatively a couple of pilots that were designed for it, and they started to grow because the efficiency of collecting one stream as opposed to two was time consuming, and often you could use a packer truck and hit more households per route than if you had to use a dual container truck, where when the first component of the container truck filled up, you had to go and dump it, even though the second component may not have filled up. So the big driver here was collection efficiency, and as a result, you saw a tremendous move from dual stream curbside collection to single stream curbside, and as a result, the single stream on the collection side was higher set out rates, higher capture rates, more efficient collection as far as cost per ton. However, this multi-stream issue really showed that processing was much more efficient than single stream. And so when you had single stream, there are things you had to contend with, and that was there's a higher contamination rate because it's harder to break materials out once they were mixed and compacted. As a result, there's a higher cost of sending materials through the system, and often you couldn't get the maximum recovery rate unless you sent it through twice, which meant double shifts often. And because there was a higher contamination rate of the output, because of market specs, you got lower revenue for the recyclables. So this processing inefficiency occurred because single stream processing facilities designed specifically for that were rare. Few have been built, and their recovery rate is higher than one would see in what most people did. was single stream. And then instead of paying the high dollar value for a design facility, many communities who already had a processing facility converted their dual stream to single stream at a much lower cost. In fact, about 10% of the cost. And that was the driver. But by doing that, their contamination rate increased significantly. One, as a result of the machinery itself was not capable of that kind of mixed waste stream going through it. So there was much more downtime. It took much longer to go through the hand sorting separation. As a result, more material backed up on the tipping floor. And often they would have to send materials through twice, which also backed material up on the tipping floor. And so here's an example of converted dual stream to single stream and the backup that's occurred. And once the material goes outside from underneath the table and the fiber gets wet, it just contributes to the loss of potential revenue as a result of market specifications. And because the single stream did increase capture rate, these facilities were designed for a smaller throughput process. And so single stream drove design capacity being inadequate. And as a result, there was an increased cost, and these costs had to be covered by the recycling. So, and one of these costs is basically the compaction of the material and getting waste glass breakage and container fluids into the loads, which basically reduced the value. So not only did you have increased operating costs, you had decreased sales or revenue for the materials because of the contamination. And so the combination of the two caused the solid waste industry to start sending signals to the municipalities that instead of being paid for the recyclables, they're actually we're going to have to pay for recycling. And so this just shows you the net economic input of single stream. There is a big advantage on the collection side. Okay, however, the processing side, we'll just take paper in this example, pulp and paper, is much higher. Once the paper was separated and sent in bales to the end user industry, they also had issues with processing this material, and it cost them more to process the materials. So there was a loss at that point of the life cycle. And thus there was a net cost lost to the life cycle of the paper if you took in both the benefit to the waste management industry and the cost to the private sector end user industry. Now, contamination, as I said, in dual stream was on the average of around somewhere between 5 and 10%. When you got to single stream, the averages jumped to 16%. But if you looked at the converted dual stream facilities to single stream, the contamination rate could have been as high as 50%. Now, from a waste management business perspective, this is fine because they would pass on the cost of processing the material, the recycling at their facilities to the municipalities, and the municipalities now had to pay to get rid of the recyclables as of getting revenue. What revenue was to be had, the waste industry collected that revenue, um, and then because many of these businesses had been consolidated and vertically integrated, they basically sent the waste that was contaminated to their own landfills, and basically that they got the tipping fee that was passed all the way down to the municipality of throwing the contaminated loads away in a landfill. And so it was a win-win-win for the waste management industry, and there's very little incentive for them to sort of not stay with single stream. And so what you start to see is that, the value of a commingled ton started to drop, especially as 2016, there was actually started to be a big drop off in the value of a commingled ton. And that is really what happened as a result of a change in international market specifications. More commonly known as the China sword. Now, understanding approximately 30% of all recyclables in the US were exported outside the country, and of that 30%, China basically had a significant amount being received. For example, 69% of all US exported plastics, except for PET, went to China. Why is China so important? So if you really look at mainland China's share of global imports for recycled commodities, if you just looked at our most common materials, recovered paper and fiber and plastics, you can see that China, for these two categories of materials, take the majority of it in the world. And until about 2016, how this material was processed was by small village or informal sector processing that was labor rich, capital poor, but the labor costs were very low. So it allowed for low quality scrap export from the US to go to China. And then there was a lot of labor going through the materials to basically separate it again for end use. So you had poor separation of single stream MRFs, and what material was sent overseas, okay, was separated again so that the end user industries had a higher quality product. We were really dependent on the labor cost in China and other Asian tigers to do this, okay? And so China versus rest of the world as far as our scrap exports, and this is scrap metal, scrap plastics, and scrap paper, you can see the China market share sort of grew with about the same sort of curve as you saw with the growth of single stream around about the same time, and became significant end user industry for our scrap material. Okay. Now, if you just look at plastic scrap, you can see that China will continue to increase taking our plastic scrap. China also took waste paper, and obviously most of it came from the US, but you can see that other countries such as Canada and the Netherlands and the UK, a lot of their waste paper imports were received by China. And as a result, especially in the US, because we were sending so much material overseas at a low cost, and it was a lower cost than sending it to our own end user industries, which demanded a much higher quality material, the waste management companies created a low valued contaminated material and could send it to China and get a revenue off that, as opposed to spending much more processing dollars to provide a high enough quality material to go to US paper markets. Because of this, there was not enough material going into recycling market facilities, and as a result, a number of these recyclers in the private sector went bankrupt, and in the long term was reducing the capacity for us to have places, even in the US, to send material, even if we wanted to. Okay, so even though 2016 China was informing the world that they were starting to do inspections of loads coming from overseas, in 2017 there was a formal notice to the World Trade Organization that they would accept materials if they met very high level quality specifications. And so they no longer wanted our dirty material, and they started to seize, or what we say, stop the import of materials into the country. And so in 2017, once they notified the WTO, you saw a tremendous drop in our exports of materials to China. And this is just a drop off in that 2017, 1 year, of going from about 75,000 metric tons down to about 6,000 metric tons in 1 year going to China. And similarly, you can see here just from 2011 to 2018, the National Sword announced in 2000 we were up at about 81% of the highest value we'd gotten for recyclables since 2011. Well, by the end of 2017, the value or the commodity prices per ton were down to about 17–18% of what we used to get in 2011. In a sense, this is roughly a 63% loss in value of a source of a single stream ton. And then if you look at other countries, we started to see a diversion of material not being accepted in China, and we were going to send it to other Asian tigers and places like Ecuador that were still accepting this relatively contaminated material. Okay, and so we just felt the market, let's just say, was signaling not to go to China but go to these other sites, and so the waste management companies changed their end user industries and depended on the processing in these countries. However, it wasn't long after the China sword that you started to see these other countries push back, and they similarly put high specifications on what was coming into the country to be recaptured. And so the external export market was shrinking dramatically, not just for the US, but for the rest of the world. And as a result, our materials are backing up. No one was taking them. And because the materials were backing up, the facilities couldn't move their materials out, so more and more materials are starting to get diverted to landfilling. And so what you're starting to see now is communities are starting to make budgetary decisions. So are the private sector. And you can see Waste Management is downscaling their recycling division because they can't move material. And they've closed or sold or exited 30 of their recycling facilities over the past few years, which is about 21% of their capacity. And they basically were stopped moving material, especially certain kinds of waste. And so certain things could not be recycled. They were basically going directly into the landfill. And at the same time, in China, besides creating higher specs, their middle class had been growing, and so there's less and less of a need for them to import materials because internally they're producing more and more materials. So even though if we cleaned up our waste act and create higher quality materials, China and other Asian tigers are basically starting to utilize the capacity of processing for domestically generated materials. And again, it's not just the U.S. Europe's paper scrap exports to China was cut in half over 2017. And this has continued as a result of the other Asian tigers shutting down or tightening their end user specifications. So just to show you the big players, the U.S. obviously is the biggest plastic scrap exporter, but Germany, United Kingdoms, and Netherlands, and France, and Europe are not far behind. So the complexity of these four trends creating this perfect storm came together, and really it was late 2016, definitely 2017, and this has continued to the present day. So what you're starting to see is in 2015, if you look at post-consumer plastic waste generated in the United States, 75% was being landfilled. In 2015, that has grown to 81% in 2018, and these figures are in metric tons. And so, similarly, what you're seeing is the recycling exports have dropped dramatically. As far as the thickness of the line you see at the bottom there. Less is being exported, less is being recycled, more is being landfilled. And if you put a dollar loss on materials that are going to the landfill, we're still, we're basically, value of unrecovered materials is in the billions of dollars annually. And so, and this was in 2016 before the China sword hit. So this number, though there's not been an analysis since then, this number is obviously has grown. So what does this mean in regards to our carbon footprint and the waste management sector and its impact on global greenhouse gases? Well, the waste management sector's emissions are only 2% of the total emissions. Um, um, but as a result of greenhouse gas methane, which comes out of landfills primarily from the waste management, but if you include wastewater sludges and wastewater treatment facilities, that's a contributor to emissions also. You can see that emissions had been dropping until about 2016, and then they flattened out. And that's because of what's happening in the waste management sector in the US, and obviously other places in the United States. So in order to really start to look at how this is manifesting itself as a result of the China sword, it's important to start to do an analysis of avoided carbon loading or carbon equivalent loading, of not landfilling or burning the material, but recovering it. And before recovering it, reusing it, refurbishing it, repairing it, and how that reduces greenhouse gases across the whole life cycle. And what we mean is looking at not having to produce a virgin product because we're reusing, refurbishing, repairing, and recycling. We're avoiding right away the inputs of extraction, both mining and drilling and harvesting of virgin materials, and the transportation of those materials to manufacturing of materials that go into products. And so if we can send things back into this life cycle, we'll avoid carbon dioxide loading. And there are many models in the world that can be used to do this. In the US, we use the waste reduction model, or WARM, that the US EPA updates on an annual basis by refining the life cycle analysis of carbon loading, as well as adding new materials to the analysis. However, the Intergovernmental Panel on Climate Change, the IPCC, has a methodology for doing such carbon footprinting in the waste sector. Scotland and Great Britain has developed their own. You've seen it also developed in other parts of Europe, as well as research and application in China. So there are multiple models, or shall we say tools, to look at carbon footprint, the whole life cycle of recovery. In the US, as I said, we just use the WARM model. And you can see that depending on how disaggregated you make your waste stream and how much is recovered versus how much is disposed, you do an avoided carbon loading analysis. And so obviously all the new common materials are part of WARM, and every year they add something new. One of the newer ones is they added carpet to the mix. And so you can see that avoided disposal means less carbon loading. And the more times you can cycle something back through production or just through repair or reuse, every cycle is the savings. So if there's cycles 5 times, you take these savings for whatever material you're talking about and multiply it by 5 before eventually it degrades to the point it has to be disposed. So I'm going to end there, and I want to thank you for listening to this. And we'll hope that this circular economy effort that we're doing will address some of the aspects of calculating and monitoring carbon that is part of the private sector refurbishing, repairing, and reuse, and not just recycling that goes through the solid waste sector. So thank you, and I'll stop right now.